students, I am Nilanjana Sanyal, an online math tutor from India. I tutor students of the IB and the IGCSE boards from grades 9 to 12. This is my website www.nsonlinemathtutoring.com. You may visit my website to know about my tutoring services in more detail. Okay. Now we are solving questions from the topic geometric sequence or geometric progression, and this is our 7th session on this topic. This is our 7th session and the final session on this topic. In this session, we will be solving 2 word problems which will be including the properties of both the arithmetic sequence and the geometric sequence, or the arithmetic progression and the geometric progression. Okay. So let us start with the first question of this session. The series sums S1, S2 and S4 of an arithmetic sequence forms a geometric sequence, and find the common ratio for this sequence means obviously the geometric sequence. Okay, so let's start with our answer. So, S1, S2, S4, what are they? S1 is the sum of the first one term of an arithmetic sequence. So, first of all, let me write for the arithmetic sequence, I am taking the first term equal to A, okay, and the common difference is equal to D, okay. So, S1 is equal to the summation of the first one term of the arithmetic sequence or arithmetic series. What is the summation of the first one term? It is the first term. So, S1 is equal to A. What is S2? S2 is the summation of the first 2 terms of the arithmetic sequence. So, it is the summation of the first 2 terms. The first term is obviously equal to A. What is the second term? Because the common difference is D, therefore the second term will be A plus D. Okay. What is S4? S4 is the summation of the first 4 terms of the arithmetic sequence or arithmetic progression. Okay. So, the first term is A plus the second term A plus D plus the third term A plus 2D plus the fourth term A plus 3D. So, this is equal to 4A plus 60. Now, I have found the expressions. This one is equal to 2A plus D. Now, I have found these expressions logically. You may use the formula to find the first n terms, the summation of the first n terms of an arithmetic series, or the summation of the first n terms of an arithmetic progression. But I have found the expressions logically. In case you do not know how to find these expressions using the formula, I would definitely be asking you to watch my videos on arithmetic series. You will be getting the concept of the arithmetic series explained in detail, and you will be having many solved problems on the topic arithmetic series. Okay. So, for this session, for this question, I have found the expressions logically. Now, they are saying these 3 expressions, they will be definitely having some value, numerical value. So, these 3 numbers are forming a geometric sequence. That means these three are three consecutive terms of any geometric sequence, of some geometric sequence. Okay. So let me write the terms. A and 2a plus d and 4a plus 6d. These three terms are the three consecutive terms of a geometric sequence or geometric progression. Therefore, there should be a common ratio existing. That is what they are asking us to find the common ratio. So, let us get the expression for the common ratio. Okay. First of all, we will be taking the first two terms. So, the first two terms will be giving us the common ratio as 2a plus d over a. So, this should be the common ratio. This should be equal to, if I take the second and the third terms, then what will be the common ratio? It will be 4a plus 6d divided by 2a plus d. Okay. This should be equal to r. Okay. The common ratio of the geometric sequence. Let us first of all, I do not know how to get r because these are in E and D, but we cannot stop. We will be continuing and let us see how can we get the value of r. First of all, we cross multiply. So, we get 2a plus d whole square is equal to a times 4a plus 6d. Okay. So, let me write over here. It is 2a plus d whole square. I am using the algebraic identity to a plus b whole square to expand the left hand side. It is 4a square plus 4ad plus d square. This is equal to 4a square plus 6ad, the right hand side. Okay. So, and we can safely cancel these two. It is a quadratic equation involving d, but it has the a factor as well, a variable as well. Okay. So, we can at most, we can find the relation between a and d. So, let us find the relation between a and d. So, I can write this as d square equal to 6ad minus 4ad will be giving us the value of 2ad. So, d square is equal to 2ad. Okay. And then if we divide this entire equation by d, what do we get? These two will be getting cancelled and this is this. So, it is d equal to 2a. Okay. This is the relation that we are getting. Now, we come to the three terms because we have found the relation between a and d. Till now, we have no clue about r, but let us at least substitute the value of d in terms of a and see what do we get. So, a, let me write over here. A is the first term, so it is a. The second term is 2a plus d. In place of d, I am substituting 2a. So, 2a plus 2a is 4a. What is the third term? 4a plus 6 times 2a. 6 times 2a is 12a plus 4a is 16a. So, these are the three consecutive terms of the geometric sequence. Hence, now we are in a position to find the value of the r, which is the common ratio for the geometric sequence. If I take the first two terms, it will be 4a over a, which is 4. Okay. If I take the next two terms, I'll be getting the same value 4. See, 16a over 4a. This is also equal to 4. Okay. So this is the common ratio value of the geometric sequence. Therefore, our answer is R equal to 4. Common ratio is equal to 4. You should be writing common ratio is equal to 4. I have written R equal to 4 by mistake. The entire answer, the full answer can be common ratio within brackets R is equal to 4 of the geometric sequence. Okay. So, let us move on to the next question. The first three terms of a geometric sequence have sum equal to 39. First three terms of a geometric sequence. Okay, so let's start with our answer. Geometric sequence. So the first term, let it be equal to A. Since it is a geometric sequence, there will be the common ratio. So the common ratio is equal to R. Okay. So since they are having the summation of the first three terms, what is the first term? It is A. The second term is AR. Third term, it is AR square. This should be equal to 39. Okay. Now they are saying if the middle term, which one is the middle term? It is AR, is increased by 66 and 2/3%. What is the improper fraction form of 66 and 2/3%? It is 66 times 3 is 198 plus 2 is 200 over 3%. Okay. So, AR is getting changed to AR plus 200 over 3% is 200 over 300 of AR. Okay. And obviously these two zeros will be getting cancelled. And this AR can be written as 3AR over 3 to make the denominators the same. So this is practically equal to 5AR over 3. Okay. So the middle term is getting converted from AR to 5AR over 3. And now they are saying the first three terms that are there. Which are the first three terms? Now A and 5AR over 3 and AR square. These now form an arithmetic sequence. Okay, there should be a full stop over here. Find the smallest possible value of the first term. This is important. Smallest possible value. Okay. So these three terms form the first three terms of an arithmetic sequence. Hence, there should be a common difference between the terms. So first of all, let us take the first two terms. It is 5AR over 3 minus A. This should be the common difference, which should be equal to the difference between the next two terms. So it is AR square minus 5AR over 3. Okay. And now let us see, we are having a single equation and we are having two variables. How can we solve them? This. But we are seeing that there is the variable A present in all the terms of this equation. So we can divide this entire equation by A. So let us do that. if we divide the entire equation by a, 5 over 3 AR divided by a gives us 5 over 3 R. Minus a divided by a is minus 1. Equal to AR square divided by a is R square. And minus 5AR over 3 divided by a is minus 5R over 3. Okay. Now this is a quadratic equation involving R. Therefore, we should be able to find the value of R, numerical value of R. Then we will be moving on to find the value of A, because that is the question. We cannot stop at after finding the value of R. Okay. So, I just want to get rid of the denominator. Therefore, let us multiply the entire equation by 3. So, 5 over 3R multiplied by 3 gives us 5R. Minus 1 times 3 is minus 3. R square times 3 is 3R square. And minus 5 over 3R times 3 is equal to minus 5R. Okay. So now I am taking all the terms to one side of the equal to sign and I'm having a 0 on the other side. So it is 3R square and it will be minus 10R plus 3 is equal to 0. Okay. So 3R square minus 9R minus R plus 3 is equal to 0, and 3R R minus 3 minus 1 R minus 3 is equal to 0. Okay. So it is R minus 3 and 3R minus 1 equal to 0. Okay. So we get the numerical values of R as 3 or 1 over 3. Now we come to, okay, let me read this tree properly. So now we come to this part. When R equal to 3, okay. When R equal to 3, what is the equation that we can take? The equation that we will be taking is this one. Okay. So when R is equal to 3, A remains as it is because we do not know the value of A. A times R is 3A plus AR squared. R square is 3 squared, 9. So 9A is equal to 39. So it is 13A is equal to 39, or A is equal to 39 divided by 13, which is equal to 3. This is one of the values of A that we are getting when R is equal to 3. What about R is equal to 1 over 3? So, when R is equal to 1 over 3, A stays as it is, AR, that is A times 1 over 3, which is A over 3, plus AR square. R square is 1 over 9, which is A over 9, is equal to 39. Okay. And we have to make the denominators the same, so it will be 9A over 9 plus 9A over 9 plus 3A over 9 plus A over 9 is equal to 39. Okay. Let me just draw a line over here and I continue. So this is equal to 13A over 9 is equal to 39, or A is equal to 39 times 9 over 13. So this gives us, this is 3. 3 times 9, which is equal to 27. So we are getting the value of A as 27 or equal to 3. This is the one of the values, A equal to 27, and this is the other value, A is equal to 3. Obviously, A equal to 3 is the smaller value of A, and the question says that give the smallest possible value of the first term. So our answer will be smallest value smallest value of the first term is equal to 3. So this is our answer. Okay. So students, this brings us to the end of this session and end of this topic, geometric sequence. We will be having our next video on geometric means. So we have solved many questions on this topic, and I am quite sure that you are in a position to solve any question based on this topic. In case you have any difficulty, you are always free to write the question in the comment box, and I will be trying to make a video answering your questions. Okay? So, we'll be meeting very soon in our next session. Thank you for watching this video till the end. Please give this video a like in case you found it useful. Please subscribe to my YouTube channel and do not forget to press the bell icon so that you get notified as soon as I publish a new video. Okay? So bye for now.